Hello, everyone. This is the explanation for the problem in the problem set number 8. So at that club meeting, I've got some internet issues, so I'm going to explain this question here. So we did talk about question number 8, which we are dividing the 31 days with the 7 days. It gives us a remainder of 3 days, which you're pushing it backwards for 3 days from Friday. So that's Monday here. And I think we talked about it in the meeting. And for number B, actually, we're having this listed out in this scenario. I don't think you could do this in another way because like there's not really a pattern for all the months. It's like some are 31 days, some are 30 days, some are 28 or 29 days. So I believe you should list that out, which gives you the remainder of 3, 2, 1, or 0. So as a result, we would just have a calendar here from January to February to March to April to May to June to July to August to September, October, November, and December. In this case, like each one in the same column is kind of like in a group, so they will appear on the same day of the week. Which means that if you have something happening on Sunday or even Monday in January, you're still having that date for April or July. Like as we are considered 2020, so it should be a leap year. That means you are having one day pushed backwards for February. As the question said, that there's a Friday for November 13th. This means that there's also going to be a Friday on March 13th because they're in the same group, I would say. So the answer would be March 13th for this one. Number C actually it's the original question, and like all the A, B, and D, I added those questions there. So you will actually only see number C in the real one. So for number C, as we have considered 2020, which is a leap year, that also applies for all the leap years, which in this case, I just copied it from here. Well, okay, so for this, you see like it asks what's the maximum number of Friday the 13th occur in a calendar year. This means like when you are having it like for the group of January, April, and July, you're having it 3 times. For October, 1 time. For May, 1 time. For February and August, 2 times. For March and November, 2 times. And for January, 1 time. And for September and December, 2 times. Also, in this case, you also need to consider the non-leap year because there are years which are not leap years. In that case, you don't really to make many changes because if you're having a non-leap year, you're having 28 days for you're having 28 days for February, meaning that it will not push backwards because it will push. So it's like 4 whole weeks with no remainders, meaning that you will have the same on February and March. So you're just putting everything, all the January and February rightwards for one day. So you're having January for this group now. So it's January and October. And for this group, you're having February, March, and November. Now you could also see that there is a maximum, which I marked here, of 3 days in a total group and the minimum of one day in these groups that are in a group. In this case, you just have the maximum number of Friday the 13th at 3, and the minimum Friday the 13th as 1. All right, and then we're going to number D. Like, when is Friday the 13th occur again on November 13th? So it occurred in 2020, and it will definitely happen again. So this also have the same concept here, but this will goes on to a larger scale, which is about years. You have 365 days for a non-leap year, and you have 336 days for a leap year. So when you're dividing it by 7, that will gives you that you are having 52 whole weeks, but having a remainder either of 1 day or of 2 days. So we can have another calendar here, which we know is the November 13th. It's on Friday in 2020. And in 2021, from 2020 to 2021, that's a non-leap year because it's from November. So we will not consider it as a leap year. So we'll push backwards for 1 day. From 2021 to 2022, it will also push backward for 1 day. For 2022 and 2023, also 1 day. But from 2023 to 2024, which you are having 2024 February the 29th here, so you will have to consider having the remainder of 2 days. So push 2 backwards, and also the same the same non-leap year for from 2024 to 2025 and from 2025 to 2026. So you will see that 2026 is in the same group with 2020. So you will have November the 13th as the Friday the 13th for November 13th again. That is a very interesting investigation, isn't it?